Okay, finally, we're going to move on to projectiles and collisions. So, quite a bit that goes into this, but nothing we can't handle. The very first thing we're going to take care of is adding client-side projectiles. And what I mean by this is, yes, eventually, when we shoot something, that movement is going to have to be controlled by the backend. So people don't cheat, they don't change the speed of their projectile, they don't change the destination location in which they want it to go to on the front end. We're going to have to control that with the back end eventually to prevent that cheating stuff. But just to get something off the ground and show you how this actually works from a physics standpoint, I want to show you how to get these projectiles moving on the front end. So that's what we're going to take care of, is adding client-side projectiles to the front end to start. So what does this consist of? Well, the first thing we need to do is create a projectiles array. Let's go ahead and do that now. So how do we create a projectiles array within our code? Well, most of our front-end code obviously is going to be within frontend.js. And why do we need to create some sort of projectiles array? Well, we are going to have multiple projectiles on the screen at any point in time. So it makes sense to create an array that contains all the projectiles rather than just create one singular projectile at a time and try to render that. So this way we're going to have really good management for projectile objects and make sure that they're all rendered and moving out on the screen at the same time. So that's basically the gist of why we're creating this array. Where should we create it? Well, we should probably be consistent with all of our variable creation, which we really aren't at the moment. So I guess I will create this near the top of our file underneath front-end players. I'll create a const called, what were we going to call this? I already forgot. What are we going to call it? We're going to call it projectiles array. So simple enough, we can call this front and projectiles to stay consistent. And this will be equal to an array. So now we have this array in which we can store projectile objects in. So now that we have this storage, we need a way to actually populate our screen with projectiles. And how do we want to do that in the first place? Well, it makes sense, I think, that when we click somewhere on the screen, we launch a projectile in that direction. So we want some sort of click event listener that listens for when we click on the screen. Now, if we look within eventlisteners.js, this is a file that I provided within the project boilerplate. We commented out this code in a previous episode. No big problem. We're going to activate it right now. So let's uncomment this code. And this is basically just calling the window.addEventListener object. And on top of this, we're listening for a click event. So whenever we click on our window, anywhere within the browser window, we're going to fire this arrow function right here, any code within it. So let's examine this real quick. Well, we are getting the angle relative from our position. Well, not relative to our position, but relative from the canvas center, which is canvas height divided by 2 and canvas width divided by 2. We're getting the canvas center, and then we're getting the angle associated with where we click relative to that center. So if I were to draw out a canvas right here, the center is going to be right here. This is represented. This is represented by the canvas width and height. And whenever we click, that is represented by event.clientY and event.clientX. So let's say that I click over here. We're populating these values with event.clientX and .clientY. And when we wrap this within a math.atan2 function like we see right here, we're getting the angle associated with the right triangle between these 2 points. So if I were to draw a right triangle, like so, we're getting this angle right here using this function. So atan2 is a whole nother story. And if you want to learn more about this function in particular, be sure to check out my collaboration with the Net Ninja. I recently did a course with them in which I explained this in much more detail. But just know, by default, what this is doing right here is it's getting the angle between 2 points. In this case, it is where we click, as represented by event client Y and event client X, and also our canvas center, which is represented by canvas height divided by 2 and canvas width divided by 2. So we're getting that angle, and then we're determining the velocity in which a projectile should move at by using this down here. So as I just mentioned, if you want to learn more about atan2 and other trigonometric functions such as cosine and sine, be sure to check out that NetNinja video that I did with him, and you'll learn more about this. But really what this is doing right here is it's calculating the velocity in which a projectile should move at based on where we clicked. So if we bring up this again and we just have our projectile and our center. If I were to click over here, we get that angle associated with that right triangle. And by using math, cosine, and sine, we can determine the exact rate in which this projectile should move at from the center of the screen. So if we clicked up there, we make a projectile, which is going to be this blue guy. And by using cosine and sine right here and assigning that to a velocity, we have the perfect values which push this projectile upwards towards this direction. If we were to move where we clicked, somewhere to down here, well, these two functions with a tan 2, cosine, sine, would push our projectile towards that direction. This is what these functions do, is it makes sure that we are pushing our projectiles in the direction of wherever we click on the screen. And then finally, we are pushing in projectiles into a projectiles array. And we are doing that by declaring a new projectile. Now, where is this new projectile coming from? Well, I added it to the boilerplate of this project to help save us some time and make sure that we're really focusing on the multiplayer parts, more so than the actual math and inner details. So let's look at this class in which we are already given. If we look at this, it's a pretty standard class, nothing that we haven't seen. We are drawing out a circle, we're updating it based on its velocity, and so forth. But if I were to change this a little bit and make things better, as I wish I did from the start of this project, what would I do? The first thing I would do is make sure that I wrap everything within the constructor within curly brackets like so. Now, why am I doing this? Well, I was looking over in eventlisteners.js when we're pushing in a new projectile, and I noticed it is kind of hard to understand what these values are. And if you ever have trouble understanding what these values might be, then it totally makes sense to give them labels by wrapping them within an object using the constructor. So if we wrap this within an object, the labels are pretty much given to us automatically. We're going to have an x, a y, a radius, color, and velocity. We want to make sure that we save this, and if we go to eventlisteners.js, well, now we need to add those labels in by wrapping all these arguments within curly brackets. When we do that, now we can say, well, what is the x position going to be for this projectile to start? Well, we'll add that label in by declaring x colon, and the x is going to be equal to canvas width divided by 2. We can do the same thing for height by adding in a y label. And then what is this 5 right here? Well, I believe it was radius. So I already know that, I'll add it in right now. Obviously, white is going to be our color, and then velocity is going to be our velocity. Since this is the same name as the argument we're using right here, we don't actually need to use the colon velocity. I believe I mentioned that before. We can just use the shorthand method by declaring velocity is going to be equal to velocity. So now that should push projectiles into our projectiles array accordingly. And we can always test this out by adding a simple console log and console logging out all of our projectiles as we push them in. So we're going to click, calculate the angle and velocity, and then we're going to push a new projectile into the projectiles array. And all of this is going to run automatically because if we look within index.html, I already added in this file. You can see right here, we're pulling in eventlisteners.js, which is calling this code, and everything should theoretically work accordingly. We might have one issue with projectiles not being available to us. If we look within index.html, yeah, it looks like that projectiles array which we created earlier might not be available to us because we're calling eventlisteners.js before we call frontend.js. So we want to make sure that eventlisteners.js comes last. That way we can have that array available to us and we can use it within eventlisteners.js right here. So just make sure that within index.html that you swap those two positions. Save all of those files, frontend.js, eventlisteners.js, index.html, projectile.js, not my Wi-Fi. And let's go back to our game and see how things look. So I'm going to refresh over here. And yeah, it looks like nothing is broken, and that's always a good start. But I do have some sort of bug, and it says projectiles is not defined. And that's unfortunate because I thought I just fixed that by swapping the location of those two files within index.html. Now, what could the issue be? Well, let's look within frontend.js, and here we go. I named this frontend projectiles, which is probably a good idea, especially for later on when we start pulling backend projectiles into this file using saga.io. So very easy fix here. We just need to make sure that we're calling projectiles right here, front-end projectiles, and that we're console logging out front-end projectiles instead. As long as we do this, go back to our game, head over to the console and refresh, click, you can see we are populating that array with projectiles. Perfect. That is absolutely what we want. Real quick, let's go back to our to-do list and make sure we're checking things off as we go. So we created our projectiles array. We uncommented the event listener. We updated the event listener where projectiles are pushed. We added brackets around the projectile constructor. So next up, we need to loop from the back of this array. I'll show you why shortly. And then we need to render these out with their update method. So let's do that next. How do we render out our projectiles now that we're populating them within our front-end projectiles array? Well, we need to go over to our animation loop. And right now, you can see we're kind of already doing this with our front-end players. We're looping through our front-end players, and then we're drawing them out. But it's going to be a little bit different for our front-end projectiles because we're using an array, not an object like we're doing for front-end players. So to loop through an array, we're going to use a standard for loop. So we'll declare for let I is equal to 0. And as long as I is less than what? Our front-end projectiles dot length. Then what do we want to do for every iteration? We want to add 1 onto I. This is going to loop from the beginning of the array towards the end. But I did mention we want to loop through the back of an array. Why? Well, the thing is, eventually we're going to be splicing out, removing projectiles from this array. So let's say we have an array right here. All these zeros are just our projectiles. Don't think anything more than that. So we have our projectiles, right? But at some point, let's say this one right here, this projectile goes off the screen first. We want to remove it from this array. Well, here's the deal. We're going to be updating all these projectiles in iteration. We're going to go start at 1, go to 2, and then go to 3. And right now, that's if we were to loop through the front of the array. But the issue arises as we might be rendering out this projectile right here. And if we immediately remove it, we say, hey, now we're ready to go to the next index of this array. But we just removed this projectile right here. It no longer exists. But if we were to try to go to the next index right here, well, nothing's actually going to exist. This projectile is going to move to the previous projectile's position. And if that's the case, we never actually call render or update on this projectile that remained at the end for the iteration in which we're trying to render out everything within our projectiles array. And when that happens, you're going to get a flash that occurs within your game between all of your projectiles. It's going to look very weird. I promise you it'll happen. So instead, we're not going to render from the front of the array. We're going to render from the back. So if we're rendering from the back, what happens? Well, we get rid of this projectile, right? But we're starting from the back. We already rendered this one out right here. And if we get rid of this one, well, what happens? This one moves to the second position right here. And that's totally okay, because if we iterate to the next projectile, which is going to be the very first one, it's not going to shift at all. We can just call render on top of it. There's not going to be any flash or anything like that, so it's going to render out correctly. So, quick little lesson for you right there on why we render out projectiles from the back rather than the front, or any object that might be spliced out for that matter. So how do we start looping from the back rather than the front? Well, I is going to be equal to front end projectiles.length minus 1. That's going to give us the very last index of our front end projectiles array. But now we need to change the second parameter right here to say we want to keep looping for as long as I is greater than or equal to 0. That means we've reached the very beginning of the array. And then for every iteration, as we start from the back, we're going to subtract 1 from the index. So we're going to go all the way from the back to the front, and then we're going to restart the process. This is generally how you loop from the back of an array. So now that we're successfully looping through the back, we can grab one specific projectile. I'm going to call this front end projectile singular. That's typically my process for naming singular objects within an array. It's just removing the S, and now this will be equal to our front end projectiles array. And I'm going to grab whichever one we're trying to loop over by referencing I as the index. So we have one particular front-end projectile. What happens next? Well, if we look within projectile.js, we have an update method which moves the x and y position of this projectile based on the velocity, and the velocity is based off of where we clicked, the angle, and so forth, which pushes it in the right direction. So really all we need to do is grab this front end projectile and then call its update method. And this isn't going to work perfectly right off the bat, or at least it shouldn't, because we're going to need to update some parameters within eventlisteners.js, but it should be a good start. Let's save this, refresh, and start clicking, and yeah, awesome. So we are shooting from the center of our screen. It is a little off in regards to where we're actually clicking, and I know I went over all that fancy angle code within eventlisteners.js, and it's just not working. Why not? So the issue here is we need to take into consideration we retinaized our game, meaning that we made sure that it's going to look as crystal clear as possible for any Retina screen users. And we did that, remember, by using this right here, window.device pixel ratio. So what we need to do is make sure that with an eventlisteners.js, we multiply event.clientX and event.clientY by this window.device pixel ratio. And why are we doing that? Well, we need to remember that some user screens might be double the size of others, and we're kind of shrinking everything down to create that retina effect. And window device pixel ratio, what does it do? Well, it either gives a value of 1 or 2, depending on how retina the screen is. And we basically need to make sure that we're multiplying this client Y and X value by that value of 2, especially for me because I'm using a retina screen. Because otherwise our angle is just going to be off relative to our canvas width and height. We're still using the non-retina version right here by default is what I'm trying to say with client Y and client X. We need to make sure that we retinaize that by multiplying it by device pixel ratio. So let's add that in there, go back to our game, and see if that fixes things in regards to where we click. And yeah, there we go, perfect. No matter where I click, relative to the center of the screen, we're going to be launching a projectile from that. Absolutely perfect. But we want to launch projectiles from the center of one of our players, not just the center of our screen. So how do we go about doing that? Well, let's take care of the center of our screen issue first. We're launching them from the center because of this value right here and this value right here. To launch it from the center of our player, we want to first grab our player and then grab the player's position on both the X and Y axis. So let's do that now. Let's say const player position is going to be equal to an object with an X and then also a Y. So what would our player position on the X axis be? How would we even grab that in the first place? Well, we can reference our front end player's object, and then we can get our particular player by referencing the socket from socket.io and get the ID associated with that socket. So we have our front end player. If we want the X position, we just add on.x, and that should give us the front end player's X position. We can do the same thing for Y by simply duplicating that, changing X with Y, and now player position for X and Y should be available to us and correct. So the first value we have right here, we want to swap out with our Y value because math ATN2 works a little funny. It takes a Y value first before the Y. So we'll swap this out with the Y value, player position dot Y, and then for our width, we'll have player position dot X. And now that's going to take care of the angle and velocity. That should shoot in the right direction relative to where our player is, but the projectile isn't going to spawn from where our player is unless we declare right here where the beginning position should be. So we're saying the beginning position of our projectile right now should be canvas width divided by 2 and canvas height divided by 2. That's the center of our canvas. We want to swap this out with player position.x and then player position.y. Given that we've done this, things should work, hopefully. We will see. So let's save, refresh, and move around. And now when I click, no matter where I click and no matter where I move, our projectiles are moving from the center of our player. You can obviously see the issue over here, though, is since we're only doing this on the front end, we're only seeing it on our local browser. The other player is not seeing any of these projectiles, but we are going to fix that in one of the up-and-coming episodes. or I guess the lesson, because this is all going to be one big one. But let's make sure that we did everything within this small little sub-lesson. Did we loop from the back? Yes, we did. Did we update our click event with device pixel ratio? Absolutely. And did we update click event with actual player's position, front end player, socket Y, X, and Y? Yes, we absolutely did. So with this, we successfully added in client-side projectiles. So next up, we are going to transfer our front-end projectiles to our back-end projectiles. Now, this consists of quite a few things, and it's a little more abstract for sure compared to what we just did previously with client-side projectiles. It's more abstract because we're basically doing the same thing, but we're not actually going to see things right away. We kind of have to move things based off of just our thoughts and the math associated with our clicks and so forth, but we're not going to see things until we actually go and render things out. But we basically have to update all the stuff on the back end first before we actually show it on the front end. And that's what's going to help us prevent people from cheating by editing their XY or their velocity and so forth. So let's get right to things and emit a new socket event on click. So whenever we click, right now we are pushing stuff into our front end projectiles array. We are no longer going to be doing things that way. We can comment out this line of code and replace it with socket.emit. What event do we want to emit? Well, a simple shoot event. That's going to go up to our backend server, but we need to submit some data with this event. Now, I'm going to submit an object full of data to help be as explicit as possible when I grab this data from the front end. So what kind of data do we need to add in here? Well, let's think about it. We definitely need an X and a Y. So where is our player's current X and Y position from where they are? So that way we know where to put the projectile initially from the back end. Well, X is going to be equal to our player position dot X. And then Y will also be equal to player position dot Y. So we have our X and our Y for our new projectile. But what else should we add? Well, I think it makes sense to add in an angle and a velocity, but let's think about this. If we are determining the velocity on the front end, that means someone can change the velocity. And that means if we're to change this value right here, which determines how fast our projectile goes on the front end, and we do this directly within the browser, well, in that case, someone is cheating. They're going to have super, super fast projectiles, and they're going to have an advantage above everyone else. So we don't want to determine our velocity right here on the front end. We can comment this out. We're going to determine it on the back end, but for now, we can grab our angle and push that up to our back end along with the X and the Y. Perfect. So we're pushing up our X, Y, and angle. Now we need to read this from our backend. So let's go over to backend.js. And where would we actually read this? Well, we don't have an event just yet. We need to make one. So we'll listen for an event with socket.on. What event do we want to listen for? Well, shoot. And we know this is going to bring us some arguments, but whenever we call shoot, first we need to respond with an arrow function. That way we call code within it. And within the arrow function's argument is where we're going to pull in that data. So I'm preemptively going to use curly brackets to say I want to pull in the X, the Y, and then the angle in which we pushed through whenever we called shoot. So we have the X, we have the Y, we have the angle. Now we need to create backend representations of a projectile. And to do that, we're going to create a backend projectiles object. So const backend projectiles is going to be equal to a new object like so. So very similar to how our backend players worked is we're going to store all of our new projectiles within this new backend projectiles object. So now, whenever we call shoot is when we're going to store in a new backend projectile. So say backend projectiles. And then we need an ID associated with each backend projectile because eventually we're going to be removing projectiles from this array or object per se whenever they go off the screen or they hit another player. So how do we give each individual projectile an ID? Well, what we can do is we can just pretty simply declare a let up here called projectile ID and set it equal to 0. And now, whenever any player calls shoot, we're going to take that exact same projectile ID. All the players are going to be sharing this projectile ID right here, and we're going to add one onto it. So anytime a player shoots, we're going to create a new projectile and update the projectile ID to make sure it gets a unique value. And what we can do is we can use this new ID by saying, I want to create a new backend projectile which has a key equal to this new ID we just created. So this new key is going to be equal to an object with no other than an x, a y, and then an angle associated with our player's data that they submitted from the front end. But now we're storing it within a backend object. But really, I don't think we need to store the angle. We need to store the velocity associated with this projectile instead. We just need to make sure that we're calculating this velocity on the back end. That way a user cannot cheat and up their velocity randomly. So let's grab the code from eventlisteners.js in which we calculated that velocity. I'm going to copy this, go back to our backend, and then right before we assign a new projectile to our backend projectiles object, I'm going to calculate this velocity const based on the angle passed through our front end. And what I can do now is replace angle right here with velocity to make sure that each backend projectile has a very specific velocity associated with it. We're not storing angle in there because it's kind of excess. It's not actually going to be used or anything like that. So it makes more sense to store velocity right here instead. Now, is there any other data we might want to store within a backend projectile? I can think of one, and it is going to be our player ID, or at least the player who shot this individual projectile. Why do we want to store a player ID in here as well? Well, when we're shooting projectiles on the screen, eventually we're going to need to determine whether or not our projectile hit another player and the projectile did not hit ourselves. So say we launch a projectile and we run into it because we're super fast. If we were to just code things without using a player ID for each projectile, well, we would say that we can get hit by our own projectiles. Doesn't make that much fun for a game. Maybe that's what you want, but in our case, my case at least, I don't want that. So in order to prevent our own projectiles from hitting ourselves, I want each projectile to have a player ID associated with it. So I'll add in that property right here and set it equal to the socket ID associated with the backend socket in which we're on. I have that accessible to us right here. And this basically just says, if you launch this projectile, this is the ID associated with the player who launched it. Simple enough. So let's check in on our to-do list. We emit a new socket event on click from the front end. We added X, Y, and angle. We added a backend event listener for shoot. We added projectiles to an object on the backend. We use projectile ID to get updated for every event in which we call shoot. We added a player ID to identify who shot what. And we did indeed use an angle to ensure that our velocity is calculated on the back end rather than the front end. So now we're going to start moving our projectiles, but through the back end. This is where that abstract part comes in. We're not actually going to see these move, but we will be updating the data on the back end for every tick. But just to show you exactly what we're doing so far and give you an idea of what's going on, let's console log out the backend projectiles object whenever we shoot. So whenever we click on the screen, we're going to emit an event to the backend, and we should call this updated backend projectiles object. So I'm going to refresh over here, and then I'm going to open up my terminal. I'll put it on the left-hand side. Make sure that NodeMon is running, and you can see this is already kind of working. Whenever I click, we are pushing in a new projectile. You'll see right now I just pushed in the fourth one. If I click again, we push in a fifth one. All these are related to where I clicked on the screen and has the exact data value associated with that event, including the velocity it should have, the X and Y it should have. This is just all represented by data rather than actually seeing it on the screen like we did for the client side. So we want to make sure that for every update going on within our backend tick, that we are updating the X and Y position associated with this projectile based on the velocity values. So let's do that. How would we do that in the first place? Well, we know our backend tick is right here with set interval. If we wanted to be extra explicit, we could say this is our backend ticker. So we're already emitting an event for updating our players. That's totally fine, but we kind of not really need to emit an event, but just update our players' positions within the set interval function right here. So let's do that now. Update projectile positions. How would we update our projectile positions? Well, we kind of need to think to ourselves, how did we do this on the front end? Let's look. We went over to animate, which for me is on line 68, and we looped through the back of an array. This is totally valid for front-end projectiles and looping and so forth. But the issue is now we are looping through an object rather than an array. So we're not going to use this backend loop method, and we can even comment this out for the time being. We're going to use the object loop method, which we used for our players. So I'm going to actually copy these 4 lines of code and set them on over to backend.js to save us a little bit of time. So we don't need any of this code within the for loop, but we do want to make sure that we are looping through not our front-end players, but our backend projectiles instead. So how do we begin updating each individual backend projectile's position? Well, let's start by grabbing the x value associated with our backend projectile. The one we're currently looping over, that is. So we'll grab all of our backend projectiles, and now we can grab one particular one by using brackets and then referencing the ID we're currently looping over. So we have one current backend projectile, the one we're currently looping over, and we can grab its x position. It's as simple as that. And now we can add onto this the velocity, specifically the x velocity associated with this same backend projectile. So let's grab our backend projectiles, grab one specific one with ID, and then add onto this, not y, but it's going to be velocity.x. And that should update our backend projectile's position on the x-axis every time we call tick, which is currently 15 milliseconds. So let's just see if it works, honestly. For every time we call this for loop right here and we call our ticker, I want to log out our backend projectile's x position. We should see this happen repeatedly. And there it goes. It's updating over time. So if I were to shoot, we should be seeing that projectile move towards whatever value this is right here on the x-axis. We're just not rendering anything out on the front end just yet. But this is what we want to see, is that value updating on the back end for every tick. Now let's do the same thing for our y position. I'm going to copy this line, paste it, replace x with y in both of those positions. And now the y value should update as long as all of our code is correct. I'm pretty darn sure it is, so I'm not going to worry about it right now. But that is going to be a good first step towards getting these moving in the right direction on the back end. So let's check off add update projectiles to backend tick. And we actually already updated projectile position for every tick. So I think I got these a little confused. What I mean by add update projectiles to backend tick is really we're going to emit this new backend projectile position to the front end, similar to like we did with our backend players. So let's just go ahead and do that real quick. I'm going to copy this line and change update players to update projectiles. This means we're going to go back to the front end with all this newly updated data. And we're going to replace backend players with backend projectiles to make sure that we have all that data associated with these new projectiles in which we're moving around our screen. So now we can actually successfully check off add update projectiles to backend tick, and that's going to let us check off the full task of transfer to backend projectiles. So now we're going to render out our backend projectiles, in which we're currently updating. So what do we need to do first? Well, we need to swap out our prior array that we were using to render out our projectiles on the front end with an object instead, just based on the way things are organized right now. We used an array prior just to get things up and running, but now that we have these working on the back end, it is time to render them out, and we need to start with this first step. So let's go on over to our code and head inside of front-end.js, and we're going to find where we created that array earlier. For me, it is on line 17, and we call this front-end projectiles. It's equal to an array. But now that we have these on the back end, we're going to change this array to an object and start rendering things out the exact same way we were with our front-end players. So it's really important, since we're changing this to an object, we might have been using array methods earlier. And we have to find wherever we are using front-end projectiles within our code to see if anything might be amiss. And yeah, definitely right here on line 78 within our animation loop, if I were to uncomment this, this wouldn't work because we're looping through an array with this code. So you can either keep this or delete it, does not matter. We also want to check within event listeners.js to see if we are using that array anywhere. And it looks like we already commented out that code right here. We should be good to go with just changing that to an object. So how do we start getting those backend projectiles into our front end over here? Well, a great place to start is going to be looking at this update players method, in which if we go on over to backend.js right here, we can see we're updating our players every 15 milliseconds on the backend. We're doing the same thing for our projectiles now. So really what we need to do is kind of duplicate this method right here, this event listener in which we're listening for those backend requests, but not related to our players, rather our projectiles. So let's start with this. We're going to use this as a nice little template. I'm going to grab line 19, paste it up above, and make sure that I close this out with an ending curly bracket and an ending parentheses. And we're no longer going to listen for update players, but rather update projectiles in this case. And that means we need to change this argument name to be as specific as possible. Whenever we update our projectiles, what are we passing through when we call this from the backend? Well, we're passing through our backend projectiles. So let's pass that on through. Whenever we get this called from our backend, we're going to pass in all of our backend projectiles. This is a capital E because that's the convention we've been using. And now we have access to all of our backend projectiles, but we need to store these within that front-end object that we declared up above. We can do that the exact same way in which we are doing things for our backend players. So we're going to basically duplicate this for in loop right here. We want to say for a const of ID, and this is the ID associated with each projectile we're about to loop over. So for each ID within our backend projectiles object, which we're passing through, we want to iterate over this and grab one specific backend projectile, which we can do by declaring a const called backend projectile singular and setting this equal to our backend projectiles. And then we're going to use that ID to select one particular projectile within this object. Now we know we have our front-end projectiles object, and we want to say if this backend projectile does not currently exist within our front-end projectiles object, well, we want to add it in there. So we'll just duplicate what we have below for our players, but using the front-end projectiles instead. So if we do not have a front-end projectile, we're going to make this singular by saying if the ID we're currently looping over within our backend projectiles is not existent within our front-end projectiles object, then we want to add it in. So using this if statement, we can take our front-end projectiles, and we're going to create a new projectile by passing through our backend ID, which we're getting right here. And we're going to set this equal to a new projectile, which we have available to us as a class within our classes folder. So how do we create a new projectile? I think the easiest way to do this is to check event listeners.js, where we were creating this on the front end earlier. It's going to be right about here. Sorry about that. I'm going to take everything in which we create a new projectile, just copy that, and go back on over here, uncomment it out. I'll grab this code and say that our new front-end projectile within our front-end projectiles object will be equal to a completely new projectile. But we're going to have to change this up a little bit. We no longer have player position available to us because it's still sitting within here in event listeners.js. So really, what do we need to do? Well, we're already determining the position of where our projectile should start within the backend. So we don't really need to do too much regarding player position, but we do need to declare where the front end of this projectile is going to be position-wise. And we can just simply get that with our backend projectile. So we're no longer going to reference our player position for X and Y, but rather our backend projectile position, which we know that we're setting already within the backend. So let me go ahead and tidy up event listeners.js, just make sure I don't have any errant code. Our radius is going to be 5. Color is going to be white to start. That's totally fine. And then we have our velocity. Velocity is going to be equal to the velocity assigned from our backend. So we also want to reference the backend projectile, but get the velocity right here. So this should, theoretically, populate a projectile. And we're not actually going to render it out on the screen just yet, because although we're populating that front-end projectiles object, well, we're not actually rendering it on the screen until we loop over all the keys within that object and call something like the draw method. So we were doing that previously with an array, and that's totally fine, but now we want to do it with an object. And we can just kind of replicate what we were doing earlier with front-end players and replace front-end players with front-end projectiles instead. So we're no longer referencing a front-end player, but rather a front-end projectile. And we're going to call the draw method on top of it, because now our position for the projectile is going to be determined by the backend. And all draw does is draw out the projectile based on whatever position properties it has. We know those are going to be changed over time from our backend, so we can just keep draw here right now. But honestly, even with this, we might see the projectile rendered out on the screen. It should not be moving yet, though. So let's just test this out, make sure we don't have any bugs. I move around, and then when I click, we should see a projectile being spawned. I think I messed something up there. And yeah, there is a projectile on the screen. There is another one, but like I said, they're not going to be moving, because really, we only took care of spawning these projectiles. We never actually moved them on the screen within this update projectiles event. So remember, this is being called every 15 milliseconds. And for the very first call, we are adding in a projectile using this if statement, but nothing else happens after that. We want to declare if this projectile has already been added, then we want to start moving it over time. So we can achieve this by grabbing our newly created front-end projectile. So we'll grab our front-end projectiles, select one particular projectile by using a bracket with the ID we're looping over from the backend, and then we're going to say that the X property for this front-end projectile should be added onto based on the backend projectile's velocity on the X-axis. So every time we call this, we're going to add on our backend projectiles, specifically the backend projectile we're looping over, the velocity on the X-axis associated with that one projectile. And we're going to do the same thing for our Y-axis, so I'm just going to duplicate that line. And now, whenever we receive this event from the backend, if a projectile already exists, well, we should be adding on to their X and Y position using the velocity we assigned from the backend. So let's save, refresh, and there we go. This is completely backend managed, which is pretty awesome. And if I refresh over here, now we should actually see the projectile moving across both screens, because remember, all backend managed, and we're emitting it to the front end for all of our clients. So if I click, there we go. We see it on both of our screens, no matter where I shoot. So pretty cool stuff right there. Now, what else can we do? I think I want to make the projectile a color just so we can determine who's shooting what and it doesn't get too crazy with just all these white projectiles. So rather than use the color of white, we want to get the color with the player who shot this projectile. Now, how do we get that particular player? Well, thankfully for us, within backend.js, when we created our new projectile, right here, whenever we call shoot, we added in a player ID to identify the player who shot the projectile. So every projectile is going to have the ID associated with it, which means we can replace white right here, grab the backend projectile in which we're currently looping over, and then we can grab the player ID associated with this backend projectile. So now that we have this player ID, we can use our front-end player's object, in which we already have populated, whenever we create a new client. And we're going to wrap this player ID within brackets. That's going to give us the one specific front-end player who shot this projectile in which we're looping over. And once we have that player, all we need to do is add in a .color property, and that should give us our projectiles to have the right color associated with their player. So let's save on both screens, refresh, and you can see we're already getting some errors right here, unfortunately. So let's try to see what's going on. It looks like, for whatever reason, we're not accessing our front-end player correctly using this method. So we definitely want to make sure that this is being called correctly. I think the easiest way to do this is to just console log out. Exactly that. See what it returns. We'll refresh. And we are indeed getting a player. So we'll look inside of this, and we are indeed getting a color as well. So we know color should actually be accessible to us, but it might not be available initially, particularly because front-end players might not be loaded yet. So if our player is not loaded yet and color is unavailable to us, what we could do is add in a question mark before the period, and this says only call the .color property if this is available to us, this player right here. Otherwise, the color is going to be set equal to null, which should give us white by default. I believe that's the default we declared over here within projectile, and there is no default actually. If we want to declare a default, we can set our color up here within the argument equal to white. We're always going to have a white projectile by default. But I think this should fix things with this little optional sign right here. It says only call.color if this object actually exists. So we'll try again. We'll refresh. And it looks like we don't have that error anymore, thankfully. This might have actually just fixed everything I was talking about. So if I start shooting, we can see the pink player now has pink projectiles, and the yellow player has yellow projectiles. Looking really great so far. But we have another issue arising, and that has to deal with we're just constantly populating this projectile array. We're still moving these projectiles on both the back end and the front end. You can see we have 26 right now, and if I keep clicking, we're just adding on to this. And that is very inefficient for our game. Whenever these go off the screen, we just want to remove them completely. That way we're not performing extra calculations, and this will be as efficient as possible. So let's check out our to-do list. We swapped our array with an object. We can check that off. We replaced our for loop with a for in loop, only using draw. We listened for our backend event by looping through all of our backend projectiles. If one did not exist on the front end, we created one using the projectile class, and if it does exist, we updated its position based on the backend position, and we also added color into this. We can say, and we also added color into this. So if we really wanted to, we could add one more checkpoint right here that says add color to projectiles. We'll check that off as well, and now we can successfully check off render backend projectiles. So now we're going to cover garbage collection. When a projectile goes off the screen, obviously we want to remove it to keep our game as performant as possible. But there's a little bit that goes into this, such as taking into account that all of our players are going to have different canvas sizes, because right now our game takes up the full width and height of their browser window. So that's the first thing we're going to take care of, is transmitting our canvas coordinates to the backend. So how do we go about doing that? Well, within frontend.js, immediately when we create a socket, we're creating a connection from the front end to the backend, right? Well, when we create this connection, an event is going to occur automatically, and it is called connect. We're kind of utilizing the same exact thing within backend.js. It's just called connection instead of connect. So if we want to listen for a connect event on the front end, right above our other socket event, I'm going to call socket.onConnect. And this is going to follow the same format we've been using for all of our other socket functions. We're going to add an arrow function in there. So on connect, whenever we create a connection between the front end and the back end, we're going to call whatever code is within this arrow function. So we can test this out by consoling out connect in all caps, save, and then refresh in the browser, and we can see that is indeed being called. So we have an event which occurs whenever we connect to the front end and we connect to the back end and so forth. But what we need to do is emit our canvas width and height over to the back end as soon as we are confirmed connected. So what we can do is we can call our socket, and on top of that call emit. And we're going to emit an event called init canvas. So whenever we initialize the canvas, we want to send up some very particular data. In this case, it's going to be our canvas width and canvas height. So I'm going to assign a width property right here equal to canvas.width. And then I'll do the same thing for height. I want to submit this value up right here. So our height value will be equal to canvas.height. And as long as we listen for this event on the back end, we should be able to get our canvas width, canvas height, and assign it to the particular player which is making this call. So now let's go over to backend.js and do exactly that. We want to listen for a particular event with socket on, and that event is going to be the same one we just created within a frontend.js, init canvas. So on init canvas, we know we're going to call an arrow function, that has an argument, and we're passing through one currently. It's just going to be an object that contains a width and then a height. So I'll reference exactly that. We have our width, and then we have our height, and now we can use these values within our backend here. So I want to assign this width and height to the front-end player that made this call in the first place. So I'm going to grab our backend player's object. We should already have created one because this is being called immediately on that connection. And after that connection occurs, we should have that available to us with backend players socket ID. So on top of this, we can assign a canvas property, and it's going to be equal to an object that uses this width and this height. So now each of our backend players should have a canvas width and height associated with them. And we can use this to determine when we should be removing particular projectiles from the screen. So let's go ahead and find where we are updating all of our players and projectiles. It's going to be down at the bottom within our backend ticker, of course. We're already looping through all of our backend projectiles, but now what we can do is track their position at all times and then remove them from the game altogether when they go off one of the players' screens. Now, we definitely have to take into account that players are going to have different screen sizes, right? So let's say one player has a screen size that's this large and another one has one that's this large. Say that they fire a projectile from the center of the screen and it starts going outwards. Well, eventually, when it hits this point, we're going to remove it from the screen, which means for the red player who has the larger screen, this is just going to be removed automatically. The red player definitely has an advantage right here. And that doesn't make for great gameplay, but in this case, we're doing the most basic game possible, so it is going to be okay. I would say if you want to fix this, you need to implement some sort of camera functionality that follows your player around the screen. So basically, your whole environment would change as your player moves. And that means that you'll be able to have multiple screen sizes no matter what, because you're playing on one large fixed map. So really, the easiest way to fix this whole thing would be to make your map a fixed size, whether it be a 16:9 ratio, like, I don't know, 1600 by 900. That would be a great way to fix this all together so you don't have to worry about different screen sizes and so forth. But I'm just trying to make sure that this is as easy to make as possible. And I want it to take up the full screen. So I just want to keep going with the method we're going with, but definitely take that into consideration if you want this to work on all screens. You either need to make one really big map with a camera or one smaller map that should fit on most people's screens. So let's continue with our method in which each player has a different screen size. We want to say for the current backend projectile we're looping over that we are going to track their position from the top, left, right, and bottom of that projectile. I want to say if the left side of our projectile, so let me draw this out. We have our canvas right here. We create a projectile in the center. If the left side of our projectile is greater than our canvas width, so right about here, we want to remove this from the screen. So how do we get the left side of our projectile when our coordinate system is within the center? Well, we can grab our projectile by using backend projectiles ID, getting the x coordinate, and then we can subtract from this the backend projectile's radius. Now, I don't believe we declared anywhere within our backend how large this projectile should be, and no, we definitely did not. So we might want to make this variable later. It's okay if it's static right now. But let's find where we are creating that projectile. We're setting our radius equal to 5. So we could either use 5 right here, or we could be a little more descriptive by creating a const called radius, or projectile radius to be even more descriptive, and set this equal to 5. So I'm going to subtract from our x position our projectile radius. That'll give us the left side of the projectile if this is greater than or equal to our canvas width for this particular player, actually. How do we get the particular player we are referencing with this backend projectile? Well, kind of similar to how we did it within the front end. So we're going to grab our backend players, and we want to select one particular backend player based on the ID associated with this one particular backend projectile. So I'm going to get this one particular backend projectile by referencing the full object using ID, and then I can grab the player ID on top of that. And we know that each of these has a canvas dot width associated with it now, because whenever we connect initially, we're also going to call init canvas, And here we set that dot canvas property with a width and a height value. So if the left side of our projectile is greater than the canvas width, then we're going to remove the projectile from our backend array. Well, not array, but object. So our backend projectiles, right here, we want to delete what? Well, this one particular backend projectile we're looping over. It's going to be very similar to how we did things up here with deleting a backend player. So whenever we shoot a projectile to the right, we're going to populate our backend projectiles array, but if it goes off the screen, we should no longer see it. Let's console log this out to make sure that this works correctly. I'm just going to console log out all of our backend projectiles, and then refresh on the screen over here, and then you're going to want to make sure that your console is open. So I'll open up Warp, and immediately I already have a bug. Cannot read property width. So this is the same thing. Our player might not have been loaded, and therefore we cannot reference a canvas or dot width property, even though we're calling set interval right off the bat every 15 milliseconds. If that's the case, we want to make sure that we use that optional chaining for dot canvas and dot width. Otherwise, we might be referencing an undefined variable right here and trying to call dot canvas and dot width on top of it. So I'm going to add that optional in two places, right before canvas and also width. Save that, refresh, and that seems to have fixed it. So great. We are logging out, it looks like, some initial projectile values. But as soon as I shoot one, you're going to see that its position is changing over time from the back end. And then eventually, once it goes off the right-hand side of the screen, we delete it from the back end altogether. So our back end is going to be much more performant in this case. We do see that projectile still there right now because we haven't removed it from the front end. We will. But we also need to make sure that we're taking into account the top, bottom, and left-hand sides of our screen, because right now we're not removing these at all once they hit the edge. So let's take that into account now. I'm going to add in an OR statement, and I'm just going to copy the same one which we created to save ourselves some time. So it might be getting a little muddy right now. That's okay. We can deal with it for the time being. But I want to get the right side of our projectile on the x-axis. So in that case, I can add on our projectile radius from the center of our projectile. And I want to say if this is less than or equal to, not canvas width, but 0, because we know that is the coordinate system in which our canvas starts, then I want to remove it from our object. That takes care of the left side, but now I need to do the same thing for the top and the bottom. Easiest way to do this is to just duplicate these two lines, paste them in, make sure that you get rid of the final OR statement, and we're going to replace every x value with y. And now we don't want to reference canvas width, but rather canvas height, and everything should work accordingly with those simple changes. So let's save that, refresh, we can move around. We have one projectile going to the right, goes off the screen, we remove it. Down, goes off the screen, we remove it. Top, goes off the screen, we remove it. And then finally to the left, if it goes off the screen, we remove it. So we have our back end managing all this garbage collection quite well. But now we need to make sure that these are being deleted from the front end. Otherwise, we're going to get these weird little bumps on the side right there. So how do we delete these from the front end if they no longer exist? Well, we can use our update players event and see where we're deleting our players when they disconnect. It's going to be right here where we loop over all of our front end players, and then if they don't exist on the back end, we're going to delete the player. We're going to do the same thing but with projectiles. So I'm going to copy this for loop and find where we are updating our projectiles. It's going to be up here. And I want to break out of this for loop right here where we're looping over all of our back-end projectiles. And instead, I want to loop over all of our front-end projectiles. And I'm going to say if a particular back-end projectile does not exist anymore within our front-end projectiles array. So we're using our front-end projectile ID right here. That's very important to know. I'm going to change this to front-end projectile ID, just to be very, very specific. And we can know that we're referencing this right here within our backend projectiles object. So we're saying if this one particular front-end projectile does not exist anymore on the back end, we want to remove it from the front end. It's really that simple, but we need to make sure that we're changing front-end players right here with front-end projectiles because that is what we're referencing. And now, given that we did this all correctly, save and refresh and start shooting off the right-hand side. we should no longer see those weird little bumps, and no, we no longer see them. Great, but I want to make sure this works on both screens, so I'll start shooting around in both and make sure that nothing is populating too much. And you can even see we're still logging out those projectiles down here within our browser. If I click one more time, now that everything has gone off the screen, we should only see one projectile within this object. And we don't even see any because I guess it's only showing the ones that currently exist when I click. And yeah, we have perfect garbage collection in place whenever a projectile goes off the side of the screen. But you can kind of see what I was mentioning earlier in the very beginning, that when a projectile goes off of this screen right here, that it's going to disappear automatically based on the width of this player's screen. So I would definitely recommend just using some sort of fixed width. In this case, I think it is totally okay to keep, just to give you guys some ideas on how this might work. But yes, I would recommend going the fixed width route and then expanding this to a camera controlled movement similar to like Slither.io if you really want to take this to the next level. But I think this should be totally okay for now. Let's head back to to-do, see what we have left. We successfully transmitted our canvas coordinates to the backend. I know that we did these two right here. If a projectile is off the screen, we removed it from the backend, and then we removed it from the front end. So now we can successfully check off garbage collection. So the last thing we're going to do is calculate the distance between projectiles and players on the back end. So when a projectile hits a player, we are going to remove both of them from the game. That means one of the players lost. So the first thing I would do here is pass our device pixel ratio as a true-false value to the back end. Because if we think about it, Retina screens players are going to have a different radii associated with them compared to non-Retina players. So we want to make sure that we're passing through the correct radii value here. So let's go ahead and start within our frontend.js file. So we know on init we're passing through the canvas width and canvas height, but we don't really have a way to pass through the actual device pixel ratio. So what I'm going to do is I'm just going to grab this const and then paste it within this object right here we're passing to the backend whenever we init our canvas. So this is going to give us a value of either 0, 1, actually I think it's just 1, 2, maybe some devices have 3. But we're going to use this to basically assign the radii of our players on the back end, and maybe also our projectiles, but right now we'll just focus on the players because we need to make sure that we have the correct radius associated with them. And the reason we're doing this as a true-false value, rather than just assigning this by the front end or some number value, is because we don't want players to be able to change this value. It needs to be determined by the back end so that we have the correct radius associated with each player. Otherwise, they can make their players really big or really small by editing the front-end JavaScript. So we know that's going to be passed through the front end, and we're going to find init canvas. That is right here. And now we can assign a radius value, not associated with the canvas actually, but to our backend player. I'm going to grab our backend player, socket ID, and say that our radius is going to be equal to an argument we're passing through. When we call init canvas, that argument is going to be device pixel ratio. And now what we can do is we can assign a radius equal to, not an object actually, but device pixel ratio times a static value, whatever we're using on the front end. So I think we were using a value of maybe 10. Let's look at player.js. Looks like we are passing this through dynamically whenever we create a new player. So let's find where we create a new player. It's going to be right here. We're currently assigning each player a radius of 10. So on the back end, I want to multiply device pixel ratio by 10. But like I said, we don't want our players to be able to cheat, because if this is coming from the front end, they could technically pass through a value of 2, which would make them really big, or pass through a value of something like, I don't know, 0.5, which would make them really small and hard to hit. So rather than just multiply that by 10, what I want to do is say if device pixel ratio is greater than 1, meaning that we have a retina screen, then I'm going to assign a radius to be 2 times 10. And this isn't very descriptive of what 10 is, so I'm going to create a const called radius equal to 10. And now we have a radius for our player. But we're multiplying it by 2 for those retina screens. Now, I'm sure there is a better way to do this, honestly, to take into account device pixel ratios that might be greater than 2, but I think all I'm dealing with here for Retina screen is 2, so I'm just going to focus on 1 and 2. So if it's greater than 1, we're multiplying that radius by 2, but beforehand, I'm going to set it equal to just that bare bones radius of 10. So our backend player's radius is going to be 10, and then if greater than 1 on the device pixel ratio side, we're multiplying that by 2 to make sure that we're getting the correct values for our player so that when we calculate collision detection, things work correctly. So I'm just going to check these off as we go. We pass device pixel ratio as a true-false value. We also set the player radius on backend based on that value. And now we need to start looping through our players within our projectile loop. So let's find our projectile loop. It's going to be down here within set interval. And we're looping through all of our backend projectiles. Now what I want to do is compare every single backend projectile to every single player that's on the screen. And if one of these projectiles is touching another player, that's when we're going to remove both. We know that they have hit. So we're going to need to do some calculations on the back end to always determine whether or not a projectile is touching a player. Therefore, we need a double for loop. So within this one for loop, I'm going to say for const player ID in back end players. And then I want to grab the one current backend player we're looping over. So I'll say a const of back end player is equal to our backend players object, and then I can pass through the player ID like so and get that one particular backend player. So this is a great start, but how do we start calculating the distance between a backend player and a backend projectile? Well, we're going to need a little bit of trigonometry. I know I said I wouldn't get too much into this, but I think I'm going to do it anyways. I'll bring out the blackboard. So here is our canvas. This entire gray thing is going to be our canvas right now. And let's say that we have a player right here. This is player 1, and then we have player 2 over here. They're launching projectiles at each other. Let's say player 1 is shooting towards player red, pew, 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 and eventually we get this one right here. So we need to calculate the distance between the projectile and this player. What is the length of this line right here, and how do we get it? Well, we're going to be using trigonometry. Just to make this even more clear, I'm going to say that we're shooting upwards towards the top right. And I'm only going to focus on that very last projectile. So we have this projectile right here, and we need to get the distance of this line. We are going to get that by getting the x distance between these 2 points in the center, and then the y distance between these 2 points. So we have a y right here, we have an x right here, and we need to get whatever this value is. I'm going to call this h to represent the hypotenuse, because that is what the longest line on a right triangle is called. So really what we need to do is square the value of x. So we're going to get the distance of x, square it, add on the distance of y, square it, and then we're going to get the square root of this whole thing. And that is going to give us h. This is what is called the Pythagorean theorem. Hopefully I have all this math right. I'm not the best at math, honestly. But this is how we're going to get that h value. And if we can get that h value, saying that this line right here is something like 50 pixels long, we can use some conditionals to say if the distance is only something like 10 pixels apart, taking into account the projectile and the player's radii, then we want to remove both of them from the screen. So it's very important that we get this distance first using some trigonometry, specifically the Pythagorean theorem. So let's start by getting the distance. I'm going to create a const called distance. You can uppercase this if you want to help indicate that this is a static value that'll never change. Doesn't really matter, it all comes down to personal preference, but distance is going to be equal to a math.hypot function. This comes with JavaScript by default, and it takes 2 values. It's going to be the x distance and then the y distance, and then it's going to give us that full distance altogether. So we don't have to square anything, we don't have to square root anything. This is just going to give us exactly what we need, but we do have to plug in the x and the y distances. So what do we need the distance between? Well, our projectile and the player. Let's start with the projectile. So I'll say our backend projectile, which we're currently looping over, and I never actually created a const for that. I'm just referencing it directly from our backend projectiles object, so I'll just continue doing that. Our backend projectiles needs one specific projectile, so I'm going to grab that and get its x position. And now from this, I can subtract our backend player, in which we currently selected, get its x position, and that's going to give us the distance between the two. That's going to be this line right here, this x distance right there. So what's next? We need to get the y distance, and we're going to do the exact same thing. If you want to make this as easy as possible, you can copy this line, paste it down below, and then just replace the the x values with y values. And that should give you the distance between a projectile and also a player as they go across the screen. So just to make sure that we have this right, let's start console logging out the distance. We're going to see this within our warp terminal because this is backend code. I'm going to refresh. And now as soon as I shoot, we should see the distance between a projectile and both of our players. Because we're looping over all of them right now, we're going to take into consideration we only want the projectile to track the distance between other players. But let's just see what it looks like right now. We should see a value getting further away from our player and also closer to another player. So one that grows and one that shrinks. So I'm going to shoot. And it's kind of hard to see because how fast that went, but let's check it out. And you can definitely see that one of these values is getting larger and one of them is getting shorter. So it seems like we did indeed code that collision detection, well, not collision detection, but distance formula correctly using the Pythagorean theorem. And this is looking great. This is exactly what we need to start. So we need to track whether or not this value is less than our player's radius plus the projectile's radius. Because if we look at this, let's say this red circle right here is a projectile, and this is a player, much larger. If we look at this, our player has a radius associated with it, and that is the distance of this green line right there. Our projectile has a radius associated with it. That's the distance of this line right there. If we add these together, we're going to get a larger line, and that's essentially when both of these are touching. We added this larger line in the middle. I know it's kind of jank. This should be a lot shorter. But the distance of those two green lines should be this long right here, meaning the two are touching. So the overall distance of our hypotenuse needs to be equal to or less than this distance, the two radii put together, in order to remove these successfully to make it look like as if they're touching. So let's take that into consideration as we code this. I'm going to write an if statement that says if the distance we just calculated is less than the radius of our projectile. Let's get that. So backend projectiles ID dot radius. And then we need to add on our other radius associated with our player. And we made sure to take into consideration the device pixel ratio. So we know our backend player has a radius associated with it. And if that is the case, then we want to delete both the projectile and the backend player from the screen altogether. So we'll start by deleting the backend projectile by referencing our backend projectiles object. And then we want to reference the very specific backend projectile we're looping over. And then we also want to delete the backend player we're currently looping over, but we need to reference the main backend player's object and make sure we're referencing player ID, which represents the player we're looping over. And then as soon as we delete these, we want to break out of the player for loop so we can go to the next projectile. We don't want to loop over any of the players for that projectile we just removed. Doesn't make sense to do. So we break out of this for loop and we continue through the for loop that we created originally for projectiles. But one issue here is if we were to shoot, this would fire off immediately because we're not taking into consideration which projectile belongs to which player. And that's absolutely integral to do because we don't want to remove our player off the screen as soon as we shoot a projectile and it detects that our projectile is touching ourselves. We need to make sure that we're not doing that. So I'm going to say and the back end projectile, which we're currently selecting, has a player ID associated with it. If this player ID is not equal to the player ID associated with the backend player we're currently looping over, then that is when we want to delete things. So make sure that you add in this extra conditional right here. Save, refresh, and let's see if we can get this working. I'm going to shoot towards the purple, and it looks like we definitely have some sort of issue. No problem. We can always debug this as we go. And it looks like I made an error in here within the if statement. We are referencing a backend projectile's radius, which probably should be based on device pixel ratio to make sure that our radii are consistent across all screen sizes. But This does not exist at the moment, so I'm just going to hard code this for the time being. I'm going to call this projectile radius, and this is undefined, so I'm going to go up to the top and make sure that I define it. This is our player radius. I'm going to make a projectile radius. And I'm setting it equal to 5 because I know that's what we declared on the front end for our projectile radius to be. And I think that should fix things in regards to our players not being removed when a projectile hits them. So let's check it out. I'm going to refresh in both spots. And there we go. Our collision detection seems to be working now. Perfect. Okay, had me worried there, but we do have a bug. And it says that backend projectiles.x is undefined at a particular point within our backend code. So let's check it out. We'll go to 121. And it's going to be right here when we're trying to calculate our distance. So it's basically saying this backend projectile does not exist anymore when we try to get the x value. And that kind of makes sense because if we look up above when we're calculating whether or not a projectile goes off the screen, we're deleting it. And then we're trying to loop over all of our backend players and use that same projectile we just deleted. It doesn't exist anymore, therefore we can't reference x or y. So whenever we delete a projectile, we just want to break out of that for loop altogether, or actually not break in this case, but rather continue. We're going to go to the next iteration of our for loop so we can render out the next projectile that is in line, rather than just not render out all together for the current tick. So we're going to use this continue statement. Just says go to the next iteration of the for loop. Don't call any other code beneath it. We don't want to reference a projectile that doesn't exist. So let's try this one more time, and hopefully we don't have any bugs with that. Our player is removed. We're looking good so far. And yeah, I think we are in good shape. I don't see anything popping up. So I want to say we're pretty good to go for this section regarding our projectiles. And I'll just double check in here, make sure we don't have any bugs. And yeah, we seem to be good to go. Let's just delete any errant console logs we have, such as our distance. We don't really need our backend players logged anymore. And I want to say we should be okay with this. So this in itself is a ton of work, and there's a lot of stuff to take into consideration when using a multiplayer game, especially trying to get this to work across all the different browser screen sizes. Tons of work, as you can see. So honestly, to be completely transparent with you guys, I have no doubt I probably messed something up there in regards to getting this working across all screen sizes and all different types of retina displays. And really, we would need to go through a lot of testing and a lot of editing to get that working, but I think this is a good start. Hopefully you guys are learning a lot with this in regards to how this works. And it's very hard for me to get all this perfect. I already spent probably 5, 6, 7 hours on just this section of lessons alone. So let's just keep on moving forward. We'll check it all out at the end and try to do our best to debug anything that pops up. But that's going to be the gist of how we calculate distance between projectiles and players on the back end. So let's check everything off right here. I'm going to minimize everything as well, just so we can see how much we got done within this one simple lesson. I don't know about simple, but this lesson. And now we can finally successfully check off projectiles and collision.